Okay guys, good afternoon. Math 2. This is graphing rational functions real quick. So we pulled out our toolkits and we reminded ourselves some of our parent functions, and this parent function is going to be about rational functions. So we have it graphed already for you, so we're just going to go through the domain and the range again. We talked about these earlier this year, but you can tell that the domain is going to be all real numbers except x equals 0, because if you notice right here, it never touches right there. It never touches. It goes really far down and then jumps way up here and really far up. The range is all real numbers except y equals 0. Okay? Now, we've got two new words we want to talk about, or one new word really, but it's the asymptote. Asymptote, all right? And the vertical asymptote, I'm going to draw this in for you, is right here. That's the red dotted line. It's not actually part of this function. As a matter of fact, it's the part of the function where this function does not exist. It's the part of the function where this function is undefined. Okay? On this case, you can tell it's the vertical line, x equals 0. Okay? There is also a horizontal asymptote. Okay? The graph never touches this blue line right here. Okay? It comes down and then over here, but it never actually touches it. And same thing over here. Even though it looks like it's very close, it never touches it. And that's the horizontal line, y equals 0. I want you to notice some similarities between the domain and the vertical asymptote, the range, and the horizontal asymptote. The domain are all the numbers except for the vertical asymptote. And the range is all the numbers except for the horizontal asymptote. So between the two of them, they cover all the numbers. Now, more specifically, I just mentioned it, but the vertical asymptote is when the function is undefined. And if I look at this function up here, when is this function undefined? Well, it's undefined when the denominator equals 0. Okay? And again, that's only for the vertical asymptote. So when does this denominator equal 0? Well, this denominator equals 0 whenever x equals 0. And that's why this says x equals 0. We'll come back into that again. Take a moment to look at that. Okay, we're also going to talk about our transformations. This is just an extension of what we've been doing with transformations of functions. We've done this with quadratics and rationals and radicals and everything. So we know that a up top, if a is negative, it's going to flip our fraction, flip our function. We know that if a is bigger than 1, it's going to stretch it, and if a is less than 1, it's going to compress our functions. That's what the a does on top. The h is going to move our graph left or right. Again, that's very typical of what we've been studying. And the k is going to move it up and down. Now I want you to think for a second. Hold on. All right, I want to think for a second. If the graph moves up and down here, okay, then that moves my horizontal asymptote, doesn't it? So the k value actually talks to me about my horizontal asymptote. Okay? So if the k moves up and down, then the horizontal asymptote also moves up and down. So we're going to have to remember that. Okay, just to fill in our notes, we'll kind of look through a couple things here. First thing I want to notice, of course, is on my function, is that this is going to move to the left 5. All right. Now, I don't have it graphed here. We do have it in our graphing calculator, and I do encourage you to do that. And if you do that, don't forget to put this in parentheses in the denominator. But anyways, it's easy to tell looking at that if I move the graph to the left 5, then I'm also moving the asymptote to the left 5. So instead of being at x equals 0, it's now at x equals negative 5 because I just moved it to the left 5. That's one way of doing the vertical asymptote, is just think about it as a graph. The other way is to go back to that definition. Remember, the vertical asymptote happens when the denominator equals 0. So in this case, the denominator is x plus 5. And by using my algebra, when does x plus 5 equal 0? Well, that happens when x is negative 5. So those are two different techniques for determining the vertical asymptote. Of course, once you know the vertical asymptote, the domain is going to be all real numbers except for that vertical asymptote. On the horizontal asymptote, I want to check to see if my graph moved. And guess what? It didn't move. Okay, I did not have any shift to the up or down, so I'm going to keep it the same. Plus, I can look over here and notice I have no k value, so it's still y is equal to 0, and it's all real numbers except 0. Okay, guys, so we're going to look at the second example here. First thing I noticed just off my transformations, this thing is going to move to the right 4. So, of course, if it moves to the right 4, then my vertical asymptote also moved to the right. So now it's at x equals 4, so my domain is all real numbers except for that 4. I do notice on my graph that there's a negative up here, so it's going to flip my graph upside down. It doesn't really change any of the asymptotes, but it does flip it. And if you look on your calculator, you should notice that it's flipped. My horizontal asymptote. Once again, did I move the graph up or down? Over here there's no k value, so no, I did not. So it's still at y equals 0, so all that stays the same. Alright, last example to look at would be this bottom one here. First thing I want to notice is this one absolutely does have a k value. This one moves up. This whole graph is going to move up 1, right? So because it moved up 1, that is going to affect my horizontal asymptote. So I'll deal with that in a minute. The 2 times here, it is in the bottom. It is going to make a compression. Actually, now that I think about it, it'll be a expansion instead, but it's a horizontal one and not a vertical one. So anyways, that's going to adjust the size of my graph, but it's not going to move it. So my vertical asymptote won't move. Like I said, the vertical asymptote, when does the denominator equal 0? This time I'm going to do it the algebra way instead of talking about moving it. It does not move, so it should still be 0, but in this case I want to talk about the denominator. So when does the denominator equal 0? Well, that's going to be whenever 2x equals 0, because that is the denominator. So if I solve that for x, it tells me that x equals 0. So my vertical asymptote is still at x equals 0, just like I thought it was going to be. Now remember, we did have a k value, so the graph does move up. And since it moved up 1, that means that my horizontal asymptote also moved up 1. And of course, because the horizontal asymptote moved up 1, that means the range has changed. These are all called hyperbolas. That's a special name. We haven't really looked at it, but that is another name for all these rational functions. You've got a couple graphs to look at on your homework, and in addition to that, page 573, 7 through 16. And we'll look to you tomorrow. Thanks.